Looking at this, another aspect that we've been looking at inside the Lex group, I think, is actually has lots of different possibilities, and is very relevant. One angle of view, one of the ways this started was, what's the equivalent of system tables inside a GQL catalog? How do we describe the metadata that's been stored inside a GQL catalog? A graph type is an example of that kind of metadata. We have a hierarchically organized catalog, another thing that was prototyped in Cypher for Apache Spark, and graph types and graphs are schema objects inside that. We want to be able to look at the whole thing. Wouldn't we like to look at it as a graph? Wouldn't we like to show the tree of the hierarchy as a graph? Wouldn't we like to look at the actual objects inside it as graphs? And then we'd be able to query our way around it and understand what was going on. The same concept as the information schema in SQL, which then requires us to be able to represent a graph type as a graph, and then to understand what that means, what the implications of this are. So something that's very evidently attractive about that is it's easy to visualize graphs. And so when people communicate their property graph schemas, what they very frequently do is give you a diagram that's got a graph, and it's got labels on the graph that tells you what the types are. And that's how you actually understand what this graph is going to look like. But if we could actually make that be systematically how we represent the graph type, and we would have serialization formats that would then easily go into visualization tools, and you'd be able to do visual editing, and then you'd be able to go round the loop and so forth. You can look at the problem of conformance from the standpoint of having a data graph and having a schema graph, which represents a graph type. And so I won't dwell on the point about having a sliding scale of schema. That's going to take too much time, but that can actually help us address the open world assumption, closed world assumption issue, because GQL at the moment actually has the open world assumption, which is you can put anything into a graph, like the Neo4j original Cypher model, or you can go to the other extreme, like Tiger Graph, and you have to have, or Kudzu, you have to have a schema, but it doesn't handle the bit in the middle. So I'm just going to finish off on this point about schema graph. A graph type is a set of node types and a set of edge types. Every element type embeds something that is called, not in the standard, but frequently and in PG schema, the paper, a content type. Content type is a record type. It's a record type where we have a set of labels and a set of property types, which you could think of together as a set of attributes. It's possible to define a key, which is a subset of the labels, which will determine the whole content type. And that means within some set of content types, that key is, or set of key labels, is therefore a unique identifier. If there's only one of them, we can use that only one effectively as a name. And so we can actually have named content types. We then take all of that and we map it to nodes representing node types, edges representing edge types, which means that we effectively can say, we have an understanding about all this information and about these clusters of information as records, which is almost like the business glossary, if you want to look at it from the standpoint of how people would actually go about sort of data modeling and data governance in an enterprise. Now we're going to then organize that into a graph context. We could also organize the same information into a table as well, because these are rows, these are row types. They're exactly the same as SQL row types, apart from the existence of this strange attribute type called label. If we've done that, then we can also worry about subtyping, the subtyping relations between content types, and we could organize a content type lattice, and then we could use that to organize a node type lattice, and then we could let that play into the more complex relationships between edge types, and we could have edge type subtyping, edge subtyping. So there's a lot of interesting possibilities there. And then just very quickly, if you take this view, you could also say that inside any graph, there lurks a core, which is actually effectively a schema. So that we've actually, if we ignore the values and we concentrate down and we concentrate down and we basically deduplicate the set of node types or of node types and edge types, we end up with something which can act as a representation of the schema of a data graph, and we could take that and we can compare it against a schema graph that came from a graph type, and we could say if one is a subset of the other, then the thing conforms. We could do that with any graphs. We could say a graph is going to act as a schema graph effectively for another graph, which means we've got a very, very tight relationship between, we're not just syntactically representing the schema as a graph. We're actually making sure that the schema is part of the graph. We can run queries over those schema graphs. If we run queries over those schema graphs, a graph pattern matching query in a language like GQL or Cypher extracts a subgraph. So we end up with subgraphs of the schema graph. Subgraph of the schema graph will allow us to do things like in a data catalog, a column must be inside a table, must be inside a schema, must be inside a database. You can't have any of those nodes without those edges between them, and they've all got to be present. That unit of integrity is referential integrity transposed to the graph world, taking account of the existence of edges as explicit, instantiations of integrity restraints. And it could also be the unit of manipulation, transactional manipulation. So I want to insert that clump, or I want to modify something so it fits with that clump. There's nothing like that at the moment in GQL. We don't have the same level of compression of the incremental validation that exists in SQL by virtue of the fact that we're actually just talking about row types on tables. So that's sort of a taste, and the other people probably have things that they want to say in this whole discussion. But I just wanted to sort of give some indication of some of the things that I think are lurking here, and that we've been talking about in many of these things for a long time. I think the job is to sort of actually try and nail them down. So I will leave it there, and I hope that there's a bit of chance for questions or comments from the rest of the audience.